Previous section we have calculated the E naught value of calomel electrode by this equation. We have derived this equation. Okay, so sorry, so here we are going to solve this problem with this equation only. Okay, so let's solve this. Now E naught of this reference electrode can be calculated as E naught of x plus 3 to x plus 0.059, okay, upon n log ksp value. Okay, so this is the value here. Now how to solve this? So x plus 3 is given as 0.5, yeah, okay, plus 0.059 upon 3. 3 is the number of electron, okay, 3 is the number of electron here. You can see that here it is 3 electrons, so that is your 3, x plus 3 to x, so that is also 3 here, so that is your number of electrons here, log of 10 to the power minus 30, so that is the value here. Okay, now let's try to solve it. Okay, let's try to solve this one. As so we can now calculate 0.5 plus, let's take it 0.06 by 3, and log of 10 to the power minus 30 is minus 30. Okay, so this is our value. So let's do the calculation. So that will become minus 10 into 0.6, so that will become 0.6. So 0.5 minus 0.6, so ultimately it will come 0.1 E naught value, and this is in minus. Okay, so remember this is in minus. Okay, so this is the E naught value of this reference electrode. Okay, this one. So when the value is in negative, okay, you can see that one value is in negative, so this negative value suggests that the cell will not work. Okay, so this cell we cannot take. E naught value should be taken as the positive value. Okay, students, so that was the problem that we have taken. Okay, so that was the problem. Okay, so now there are various other problems regarding the calomel electrode. So let's do some problems there. Problems regarding the calomel electrode reference electrodes. Okay, so let's see some more things here. Now, what is the, let's take one problem. What is the calomel standard reduction potential of calomel electrode when chloride ion concentration is 0.01 molar? Let's suppose this is the problem we are getting. Okay, so we want standard reduction potential of calomel electrode when the chloride ion is 0.01 molar. Okay, so I should okay, now one more thing, I should write it as only reduction potential. Rp is the reduction potential here, not the standard one, because standard one means 1 molar and all that. So we are just talking about the reduction potential of calomel electrode when chloride ion is 0.01 molar here. Okay, this one. Now how to solve this one? We have seen this is the reduction Hg2Cl2 plus 2 electron to give 2 Hg plus 2 chloride ion. So this is our normal reaction of reduction of calomel. So that is your solid, this is solid, and this is aqueous. Okay, so here there is some no equilibrium is there, so instead of ksp we will write q. So when there is non equilibrium conditions. Okay, so for that we write Q, that is your reaction quotient. Reaction quotient. Okay, so we take the standard Nernst equation. Standard Nernst equation. So what is the standard Nernst equation? Standard Nernst equation is E. Okay, E half cell. That is because there is only reduction. So it is half is equal to E naught of calomel electrode minus 0.059 upon N log Q. Okay, so that is our standard Nernst equation. So by that we can solve this one. Okay, so first you know that E naught of calomel electrode earlier we have calculated, that is your 0.26. Some of the value in the other books is 0.25 or 0.24, so but we are taking it 0.26. Okay, now what is the number of electron here? N is the number of electron, 0.059. Okay, stick 0 here, 0.059 upon 2. Okay, log Q. Okay, 2 is the number of electrons here. Now how to write the Q? Q is your reaction quotient, sorry. So it is your product upon reactant. Okay, now in this reaction, that is your Hg2Cl2 plus 2 electron to give 2 Hg plus 2 chloride. Okay, this is solid, so it is counted at 1, and chloride ion is aqueous, so we will take it as some concentration which is given as 0.01 molar. So only chloride ion square will be there because it is 2 here, solid is taken as 1, and chloride ion is 0.01 molar whole square, so that will become 10 to the power minus 4. So that is your Q value, 10 to the power minus 4. Okay, now let's solve this. So E half cell is equal to 0.26 minus 0.06, approximate value of 0.059, divided by 2 log 10 to the power minus 4. Okay, so let's solve this. 0.26 minus 0.03 into minus 4, so that will become 0.26, that becomes minus 0.12. Okay, minus 0.12 here, and it will become plus. Okay, it will become plus here, so we will get 0.38. So that is your E half cell. Okay, that is your E half cell. So that is how we can calculate this value. Okay, that we can calculate this value. Okay, so that is your reduction half of calomel electrode when the concentration of chloride ion is given to you. Concentration of chloride ion is given to you. Okay, students, so the that is a problem you can encounter. That is a very easy problem. Okay, that's a very easy problem, you can see. Another thing is that you can get another type of problem. Suppose, let's take this one. What will be the E cell when AgCl and calomel electrode is coupled? Okay, calomel electrode is coupled. So these are the, okay, so we couple these two electrode, and what will be the E cell. Now when they say just this information, so you have to see that this is the standard condition. Okay, so the question is asked under the standard condition. Standard condition. Now how to solve this one? Okay, how to solve this one? Okay, so this E naught AgCl value is 0.2227. Okay, and E naught of Hg to Cl2 to Hg value. Okay, so sorry, I should write it as the reverse order. Okay, AgCl to Ag, that is reduction, and Ag, that you know, that is 0.26 volt. Okay, this, suppose this is given to you, so what you have to do, you have to do nothing, just try to solve this. So what is the solution for this one? Is that whichever value is less, you have to put the negative sign there. Okay, what is the condition? Whichever value is less, put negative sign before that. Okay, so which value is less? AgCl value is less, so what will be our E cell? E cell will be 0.26 minus 0.22. We are just taking to 0.22, so that will become plus 0.04. So that is a positive value, it means cell will run. Okay, it will produce electricity because that is the positive value here. Plus 0.04, that is a positive value. Okay, that is one aspect of the problem. Now suppose they gave you another sort of problem, like this one. Okay, like this one. What you have to do is, suppose they give you AgCl Ag electrode having the chloride ion concentration 0.1 molar, and Hg2Cl2Hg electrode, okay, having the chloride ion concentration 0.01 molar, and they are coupled. Okay, both of them are coupled with each other. Now what is the electrode potential? E naught value will remain same. E naught value for this is 0.222, and E naught value for this is 0.26. This is the E naught value. Okay, now how to see, okay, which one will get reduced, which one will get oxidized? Okay, how to see that? Okay, so you don't have to see this one. Okay, just you have to see the E naught value there. You have to see the E naught value. Okay, and first you have to see the E naught value, that is a 0.222, 0.026. So this is your E naught value. Okay, now how to find this? First you have to do two things, because when they are coupled, you know, when they are coupled, so let's go to the solution. Okay, so this is your E naught value, so they are coupled. So what is the E cell value? So question is, what is E cell value? What is the E cell value? Okay, now let's see this. Okay, if you know that E cell is positive, cell will run. Cell will run. Okay, if E cell is positive, cell will run. So that is one aspect. Okay, So we have to, I am showing you both the cases, okay, in which one time silver chloride is reduced, another time your silver chloride is oxidized. So we are taking case by case, okay. So we are taking both the cases. In one case only E cell will be positive, and that will be our answer. Now how to solve this one? Let's take this as, suppose, AgCl plus electron, and it gets reduced to Ag plus chloride ion, that is solid, and this is your aqueous. So that is the reduction. Okay, we are taking as this as case 1 here, and then mercury, that is your calomel, is oxidized. So how we can write calomel is oxidized? Okay, Hg, 2Hg plus 2 chloride ion to give Hg2Cl2 plus 2 electrons. So that is your oxidation. Okay, I should write in the same color so that you can easily see that one. Okay, so 2Hg plus 2 chloride ion to give Hg2Cl2 plus 2 electrons. So that is your oxidation. So that is your case 1. Okay, so in case 2 opposite will be there. So let's solve this one. So when we are solving this one, we have to cancel out the electrons. So we have to multiply this AgCl into 2. Okay, so let's multiply this equation by 2 here. Okay, just clear this out. So let's multiply this equation by 2 so that we have 2 electrons. So after multiplying, what we are getting is 2 AgCl plus 2 electron to give 2 Ag plus 2 chloride ion, and 2 Hg plus 2 chloride ion to give Hg2Cl2 plus 2 electron. Now we have 2 electron on both the side. Okay, so you can cancel out. So let's cancel out 2 electrons and then write the final equation. So what is our final equation? Final equation is 2 AgCl plus 2 Hg plus 2 chloride ion to give 2 Hg plus Hg2Cl2 plus 2 chloride ion. Okay. Now this chloride ion is from silver chloride electron. This one, just I am writing silver, S silver, and this is from mercury, Mer. Okay, this one. Now above we have taken, okay, chloride ion concentration for this one is 0.1. Okay, here it is 0.1. You can see that, and here it is 0.01. Okay, this one. So now we cannot, okay, don't cancel out the 2 chloride ion here. Don't cancel out this one. You cannot cancel out because their concentration is different. So don't cancel out if concentration is different. Okay, don't cancel out if concentration is different. That you have, that is the key that you have to remember. Okay, this one. Now except chloride and all are solid. This is solid, this is solid, this is solid, this is solid. So for Q we can write as chloride ion whole square from silver divided by chloride ion whole square from mercury, and we can write this one as chloride ion from the silver. Earlier you can see that it is 0.1, and from mercury it is 0.01. Okay, so 0.1 whole square, 0.01 whole square, so that will come 10 to the power minus 2 upon 10 to the power minus 4, so that will become 10 to the power 2 ultimately Q. Okay, Okay, so let's write the E cell value, Nernst equation. Nernst equation. So that will become E cell is equal to E naught cell minus 0.059 upon n log q. Okay, E naught cell is 0.04 that we have already calculated. Okay, sorry. So that is your minus 0.059 upon 2 log 10 to the power 4. Okay, so this is your equation. Now let's see whether it is coming as positive or negative. So 0.04 minus 0.06 by 2 into 4, so that become 2. So here 0.04 minus 0.12, so that will come as negative value, that is your 0.08, and that is the negative value. This negative value means cell will not run. Cell will not run because of negative value. This is negative value. Okay, so cell will not run. In this case, the cell will not run. So here silver, which is reduced, silver AgCl, in this silver is reduced here. Okay, silver is reduced in AgCl, so that is not the case. So opposite case will be true. Okay, opposite case will be true. So here opposite case, that is your second case, we can take as this one. So in this, Ag plus Cl ion to give AgCl plus electron, so that is your oxidation, and mercury will be reduced, Hg2Cl2 plus 2 electron to give 2Hg plus chloride ion, so that is your reduction. So that will perceive, and you have to solve in similar manner. Solve in similar manner, and after solving you will get that E cell as plus 0.08, and this will run. Okay, cell will run. So that's how you can solve this problem very easily. Okay, this is the solution of the problem. Okay, fellas, so this is one of the problems that you can face, because this is very easy to solve. I told you how to solve this one. Okay, and they can give you IT means, IT jam, even in net exam they can give you. Okay, now let's take one final problem there, one of the final problem. Okay, now see, at what concentration of chloride ion in calomel electrode, E naught calomel is same as E naught of Hg2 plus 2 to Hg. Okay, this one. So how to solve this one? Let's see the answer there. Now, what is the equation that we solved? E naught calomel is equal to E naught of Hg2 plus 2 to Hg plus 0.059 upon n log Ksp. Okay, so this is not the Nernst equation. Remember, this is not Nernst equation. We derived it in the previous part. Okay, so here instead of log Ksp we have to take the Q. So we have to take the Q instead of this. So we will write E naught of calomel, E naught of Hg2 plus 2 Hg plus 0.059 upon n log Q. So Q there is chloride ion whole square. Okay. So when E calomel is equal to Hg, so we can write that E naught calomel is equal to E naught calomel plus 0.059 upon n log Q. Okay. So this will become 0. Okay. This one. So that will become, so log Q is equal to 0 means Q is equal to 1. So chloride ion concentration should be 1 molar. So that is the answer. So this is your perfect answer, 1 molar concentration. Okay. So they can give you simple questions in integer type on every, okay, there we have to fill the numbers there. So best wishes from me. So that's over from for calomel electrode. Okay. Please write in the comment what next you want. Okay. And what are my flaws in the videos. So let's close this session. Okay, students.